Look at half angles and the last part of some to plot that identities. So in talk of half angles, we're going to continue from where we ended. So we ended on double angles. So for sine 2x, this one was giving us which one? 2 sine x, then cos x. In this one you remember very well. So one was the first one, and then the second one was, let's say you want to find, okay, so this one was the second one, which is cos 2x, which is equal to cos squared x minus sine squared x. I think you remember very well. And then when it comes to tan 2x, this one was giving us which one? It was giving us 2 tan x, then divided by 1 minus it. Then here we're going to have tan squared x. I think these identities you remember very well, right? So when you talk of half angles, we're going to derive these half angles from these identities. Now before I go any further, you're going to agree with me that from this identity we came up with two identities, because you know to say that sine squared x plus cos squared x, what are you going to have? You're going to have 1. So if we make the assumptions whereby we take this one here to the other side, we can make cos squared x the subject of the formula. So therefore we're going to have something like this one. So we can take this one here and put it here. Alright, so what we are going to obtain is going to be cos 2x, and then it's going to be equal to 1 minus 2 sine squared x. So this one was the first identity when it comes to this one. The second one, we do likewise. Here, instead of taking this one, we're going to take this one to the other side. Then what are we going to have? We're going to have sine squared x, which is going to be equal to 1 minus cos squared x. So if we take this one here and then put it here, what are we going to have? We're going to have cos 2x, which is going to be equal to 2 cos squared x minus 1. This one is the second identity when it comes to this one here. Now, let's talk about the half angles. So usually for half angles, we focus much on these two. Okay? So let me just click this one here. And I take this one up. Alright, so we are focusing on this one. So in talk of half angles, the letter which is representing the angle here is x. So if we multiply the angle by half, what are we going to have? You know to say that half is this one here, isn't it? Now if you multiply by the theta, what are we going to have? We're going to have something like this. 2 open bracket and then x divided by a2. And this is what we are going to have, isn't it? But you know to say that this one and this one here, they can cancel each other. So what are we going to have? We're going to have something like cos x. That is what we are going to have. So without wasting time, let me just write x. So we are going to have cos x, which is going to be equal to 1, then minus 2 sine squared, and then open bracket x divided by a2. So we are coming up with the identities for the half angles, meaning we are making sine x divided by a2 as the subject of the formula. So what are we going to do? We take this one here to the other side, and also this one here to the other side. So therefore we're going to have 2 sine squared open bracket x divided by 2, which is going to be equal to 1 minus cos x. From here we can see that we can divide by a2, even here by a2. So what are we going to have? We're going to have sine squared open bracket x divided by 2, and this is going to be equal to 1 minus cos x, then over 2. From there, you know to say that here we are having a 2. So I can just introduce the square root to both sides, even here. So now you know to say that the square root can be both positive or negative. So these, they are going to cancel each other. So sine open bracket x over 2 is now going to be equal to plus or minus root of 1 minus cos x divided by 2. So now this is very, very important to understand, because you're going to be lost here when it comes to the signs. Which sign are you supposed to use? So these signs, they come about when we use the quadrants. Okay, let me just write it nicely. If we use the quadrants here, you're going to find that we're going to have something like this. This is the first quadrant, and all the trigonometric ratios, they are positive. Second quadrant, only sine is positive, the rest they are negative. Third quadrant, only tan is positive, and then the rest are negative. In the fourth quadrant, you're going to find that only cos is positive and all the rest they are negative. Alright, so this is very, very important. So if in an exam they give you something like find the exact value of sine, let's say 105 degrees, and you want to use the idea of half angles, you can use half angles, or you can just go direct by using the special angles. Right? So there are two ways here that you can use, but here we are talking about half angles, so I'm going to use the idea of half angles so that we see what I'm talking about. So actually, for us to have 105, this is just the half of the original angle. So for us to know the original angle, always you need to multiply by 2 if you want to use this idea of half angles. So if I multiply by a 2, I'm going to get 210. So 210 is the actual angle. Where is this 210 coming from? So if you say x is 210, okay, so if x is 210, meaning you're going to say 210 divided by a 2, then definitely you're going to get 105. But if you say you put 105 here and then divided by a 2, you're going to get a different angle. So that's the reason why we multiply by a 2 here. So that is very, very important to understand. Now let me just do this. If we say we have, if we say we have 210 here, then this one is going to be equal to, I'm using this one here. We know to say that 210 is in which quadrant? It is in the third quadrant. Now what happens to the sign for sine theta? In the third quadrant, sine is negative, so that is the use now of these signs here. So if the angle was in the second quadrant, meaning here we would have taken the positive, but since it is in the third quadrant, we are going to take a negative. In the fourth quadrant, still we are going to get a negative, so we are going to say negative. So that is how you determine if you are going to have a negative or positive. Then here we have 1 minus cos 210, then divided by a 2. From here, if I divide, I'm going to get 105 definitely, and this is going to be equal to negative root of 1. Now as you can see, 210 is not the special angle. So how can you find the special angle? Very simple. You just say 110, or let me just say 210 minus 180. So definitely here we are going to get 30 degrees. So 30 degrees is among special angles that we have. Okay. Alright, so what we are going to do here, this one here can be also be written as cosine 30, then divided by a 2. Now let me just draw the special triangles. I think these ones, we talked about them, but they are very, very important to remember them and also understand them. Alright, so here we are going to have a 30, then here we are going to have a 60, this is 90, here we are going to have a 2, here we are going to have a 1, then here we are going to have a root of 3. So we need to say that cos x is equal to adjacent divided by hypotenuse. This is 30, so the adjacent is this one, the hypotenuse is this one. So that is what we are going to have. Okay, so we have 1, then minus root of 3 divided by a 2, then divided by 2. This is what we have. Now as you can see here, we can say to multiply by 1, that is 2, then minus root of 3. What are we going to get? We are going to get 2 minus root of 3 divided by 2. So as you can see here, these they can do what? Here we can multiply by saying we have 2 over 1. As you can see here, it is more like we're having 2 divided by 1, so they are going to undergo reciprocation. As a result, these two, they are going to cancel each other. Then what are we going to remain with? We are going to remain with 2, let me say root of 2 and root of 3. Then here we have a minus. Right, so these, they are going to cancel each other. As you can see, they are going to cancel each other. Then what are we going to remain? We are going to remain with root of 2 minus 3. So as you can see here, we're also having a minus, so I need to enclose them inside the brackets. But if you want to multiply, you can also multiply. So if I multiply, what are we going to have? We're going to have positive 3, then minus root of 2. Then from there, now you are done. Alright, so let's try also to look at the second identity for half angles. Alright, so from here we have made this one here the subject of the formula where we're dividing by 2. So the second one, now we are going to focus on this one. So what are we going to have? We're going to have cos x. Since here we're dividing by 2, this is what we are going to have. Then here we're going to have 2 cos squared x divided by 2, then minus 1. Collecting the like terms, we are going to have cos squared open bracket x divided by 2, then 1 plus cos x. So from here we can divide by 2. Then what are we going to have? We are going to have plus or minus root of 1 plus cos x divided by 2. So you know where this one is coming from. You cancel this, then you square both sides. You cancel this one, so this one can be positive or negative. So this is the second identity for cosine. So this is cos open bracket x divided by 2, then this is going to be equal to plus or negative root of plus 1 plus cos x, then divided by 2. Let's talk about the one for tan. So we know to say that tan is sine divided by cos. So from here we can say, if we introduce half, what are we going to have? We're going to have x divided by 2, and this is going to be equal to, what is the formula for sine? It is plus or minus root of 1 minus cos x, then divided by 2. Then for sine, let me say for cos, it is plus or minus root of 1 plus cos x divided by 2. So one thing that you need to understand here is that when it comes to these identities for the half angles of sine and cos, is that they are going to have same formulas, but the only difference is the sign. Okay, here we are having a negative and here we are having a positive. For sine, you are going to have a negative. For cosine, you are going to have a positive. So as you can see here, you are going to agree with me that these, they can cancel each other. Okay, why are they cancelling each other? Let me do this. Plus or minus 1 minus cos x, then divided by 2. So here we can say multiply by, we are going to have a 2, then divided by 1 plus cos x. You know where this one is coming from. They are undergoing reciprocation. So since they are having the same squares, so we can just say we introduce a big square and then we say plus or minus, then this is going to be cos, or 1 minus cos x divided by 2, then multiply by 2 divided by 1 plus cos x. So these, they can cancel each other. Then what are we going to remain with? We're going to remain with plus or minus root of 1 minus cos x divided by 1 plus cos x. So this is the formula for finding the half angle of tan. So tan open bracket x divided by 2. This is the formula that you're supposed to use. So other formulas that you can use, you can also use this one here. You can also use this one, sine x, then divided by 1 plus cos x. You can also use this one here, 1 minus cos x divided by sine x. These are also formulas that you can use. So where is this one coming from? This one is coming from when you use this idea of saying you have tan 2x, which is equal to 2 tan x divided by 1 minus tan squared x. So you can use this one here to come up with this. Alright. So these identities, they are very, very important. So let me just see if I can give you one example so that you can appreciate. So let's say, for example, if sine x is equal to negative 3 divided by 5, and the range is 180 less than or equal to x less than or equal to, let me say 270 degrees, then you have been told to find the exact value of the first one is cos open bracket x divided by 2. Then the second one is tan x divided by 2. Then additionally, let me also add this one here. So this one you're going to try on your own. Secant, then open bracket x divided by 2. So this one you're going to try on your own. Okay, so let's start with this one here. So now, if you use the idea of SOHCAHTOA, you know to say that sine theta or sine x is equal to opposite divided by adjacent, then cosine x is equal to adjacent divided by hypotenuse. So meaning to say that this is sine x, isn't it? So we have opposite as 3 and hypotenuse as 5. But what about cos? Cos, do we know what cos is? Cos is adjacent divided by hypotenuse. So we don't have the adjacent. So let me just draw a triangle here so that you can appreciate what I'm talking about. Let me do this one here. Alright, so the hypotenuse is 5. Do this, the hypotenuse is 5, then the opposite is 3. So you can just imagine that the angle is somewhere here, which is x. So to find this one here, let me just put 4 here because we know that this is a 3, 4 and 5 triangle. So you can try, this is hypotenuse, you use the Pythagorean theorem. You say c squared is equal to a squared plus b squared. So definitely this one is going to be 5 squared and this is going to be 3 squared plus b squared. So b is going to be equal to root of, so in this one, do the computation, is going to be 9, this one is going to be 25, so 25 minus 9, you're going to get 16, then the root of 16 is going to be what? It's going to be 4, so b is going to be 4, so this is where now this 4 is coming from. So from here you can say cos is going to be equal to, cos x is going to be equal to, we have the adjacent, which is 4, and the hypotenuse, which is what? Which is 5. Now according to the range which they have given us here, we are starting from 180 to 270. That is very, very important also to consider. Okay, so the range is from 180, which is here, to 270, meaning to say that this is in the this range here, it is in the third quadrant. So now what happens to cos in the third quadrant? It is negative. So here we're supposed to put a negative because this range here, it is in the third quadrant. So we have negative 4 divided by 5. Now what about tan? Tan in the third quadrant is positive, and you know to say that tan is equal to opposite divided by adjacent. So the opposite there is 3, then the adjacent is 4. So this is what we have. Alright, so let's find out the values. So I'm going to start with this one here, which is for cos. So what is important here is u first by, okay, let me just do this. So what is important here is you finding these numbers here. Okay, so let me start with cos. So we know to say that the formula for the half angle of cos is plus or minus root of, so we have 1 then plus cos x then divided by a2. So from there now we know what cos x is. What is cos x? It is negative 4 divided by 5. Now this sign here, you take it according to the range. Cos is negative in the third quadrant, so we're going to add a negative there. So here we need to put a negative instead of a positive because the range there is showing that it is in the third quadrant. So we have 1, since here we're having a positive and this one is negative, so I'm going to say minus 4 over 5 then divided by a 2. And 5 minus 4, that is 1. So we are going to have 1 divided by 5 then divided by 2. So as you can see here, when this one here undergo dislocation, what are we going to have? We're going to have 1 over 5 then multiplied by 1 over 2. So this is same as the negative root of 1 divided by 10. So we know to say that the root of 1 is 1. Okay, the root of 1 is 1, then the root of 10 we don't know. So this is a surd, so we need to multiply by a conjugate. So when I multiply by the conjugate, I'm going to get negative root of 10 divided by 10 because root of 10 multiplied by root of 10 is 10. So this is what we are going to have as our final answer for the first question. Now there is also this idea of you finding these values that we have found for cos, let me do this, for cos x and tan x. So it just depends on how you want it to be. You can also use this method of saying, since we know that sine squared x plus cos squared x is equal to 1, and we know to say that sine x is equal to negative 3 divided by 5. So you can say, since here we're having a square, so I'm going to open the bracket and then say negative 3 divided by 5, and then we square this one. Then see what we are going to have. So this one is going to be 9, this one is going to be 25. So when this one crosses an equal sign, what are we going to have? Or when this one crosses an equal sign, we are going to have cos squared x, which is going to be equal to 1 minus 9 over 25. So 25 multiplied by 1, that is 25, minus 9, that is 16 divided by 25. Now you know that here we're having a square, so we can just introduce the square root to both sides. So as a result, cos x is going to be equal to, what is the root of 16? It is 4. Then the root of 25 is what? It is 4. Okay. Now according to the range, it is in the third quadrant, so meaning I need to add negative here. So you can also use this idea. Now finding tan, you know to say that tan is equal to, tan x is equal to sine x divided by cos x. So you know to say that cos x is this one here. Then say sine x is this one here. Then cos x is this one here. So you can just put sine x here and cos x. Still are going to get the same answers that we have found. Let me just do this. So we know to say that cos x is equal to negative 4 over 5. Then tan x is equal to, since tan is positive, we know that, so it is opposite over adjacent. Alright, so from here let me try to answer this one. So we know to say that tan x divided by a2, this is equal to plus or minus root of 1 minus cos x, then divided by 1 plus cos x. So apart from this one here, you can also say this is equal to sine x, if you remember very well, then divided by 1 plus cos x. You can also use this idea of saying 1 minus cos x, then divided by sine x. So still you are going to get the same answers. So since the range here, it is in the from 180 to 270 is in the third quadrant, so meaning tan is positive. So which one should we use? Let me use this one here. Then you can use this one and also try to use this one. So we know to say sine is negative 3 over 5. Okay. Then divided by. So we have a 1. Then what about cos? Cos, since here we're having a positive and here we're having a negative, so we can just say minus 4 over 5. And this is going to give us negative 3 over 5. So 5 multiplied by 1, that is 5, then minus 4, that is 1 over 5. So 1 over 5, if we are dividing here 1 over 5, what is going to happen is that these two numbers, they are going to reciprocate if I introduce a multiplication here. So let me just introduce a multiplication. So we are going to have 5 divided by 1. So this, they can cancel each other. As the result here, I'm going to get negative 3. So this is how you're supposed to answer this one. Let me also try to answer this one. So we have 1, then minus. We know to say that cos x is equal to this one. So here we're going to have a positive, which is 4 over 5. Then divided by sine. What is sine? Negative 3 over 5. So this one multiplied by that is 5 plus 9, but let me say plus 4, that is 9. So 9 over 5. Then here we can see that these, they can undergo reciprocation if I multiply here. So I'm going to have something like this. So these, they can cancel each other. And then I'm going to remain with 9 divided by 3, which is going to give me negative 3. So as you can see, we're just getting the same answers. Okay, so you can try that, which is sec, then you have x divided by 2. So let me just give you the hint how to go about this one. You know to say that, okay, let me do this. You know to say that sec x is equal to 1 over cos x. So meaning to say that sec open bracket x divided by 2 is same as 1 over cos open bracket 1 over 2. Okay, so you know to say that 1 then over, what is the formula for cos x divided by 2? So you are going to agree with me that this is equal to plus or minus root of 1 plus cos x divided by 2. So from here you can work out, you know what cos x is, and you know that tan, or let me just say secant, is the opposite of cos. So if cos is negative in the third quadrant, meaning secant is going to be positive. I guess you have understood that one. So let's try to verify this identity, where we're going to have 2 cosecant x, then cos squared x divided by 2, and this is equal to sine x, then divided by 1 minus cos x. So you and I, we know to say that this one here, cos squared x divided by 2 is equal to which one? It is equal to 1 plus cos x divided by 2. Where is this one coming from? You know to say that cos x divided by 2 is equal to plus or minus root of 1 plus cos x divided by 2. Now for us to have this one here, definitely we add something like cos squared x divided by 2. So for us to have this one here, we're going to eliminate this one. That's the reason why we are having this one. So that is one thing that we need to understand here. Now, so in the place of cos squared x divided by 2, I'm going to put this one. So we have 2 cosecant x, then open bracket, we have 1 plus cos x, then divided by a2. So from here we can see that these, they can cancel each other. Cosecant is same as 1 over sine x. Alright, then here we can open the brackets and then say 1 plus cos x. So 1 multiplied by 1 plus cos x, we are going to get 1 plus cos x divided by sine. So from here you can see that this one is different from this one. So what are we going to do? We need to multiply the numerator by the conjugate and also the denominator by the conjugate. Now most of the times we consider the denominator part for the conjugate, but in this case here, the one that we're going to consider here is the numerator, because it is having 1 plus cos x. What is the conjugate of sine? You can't say it is negative sine, no. So this one is the one which is having the conjugate. So we have 1 minus cos x, then divided by 1 minus cos x. So from here, you remember I told you that you need to multiply the first part with the first part, the last part with the last part. And then this one, we are going to have sine x, open bracket, 1 minus cos x. So from here, you can agree with me that sine squared x is equal to 1 minus cos squared x. So in the place of what we have here, you can just put sine squared x. So from here you can see that here we can cancel sine x, and then here we can also cancel sine x. So we are going to remain with sine x, which is going to be single, then divided by 1 minus cos x. And so let me just write it here. Sine x divided by 1 minus cos x. So as you can see, this one here is similar to this one. So ends shown. So this is how you're supposed to answer that one. So now let's talk about the sum and product of trigonometric identities. Now to start with, let me talk about product to sum. Product to sum identities. So the first one that you need to know is sine. So sine A cos B, this is equal to half, and then open bracket sine, open bracket A plus B, then close. Then here we're going to have a plus, then sine, open bracket A minus B, then close. For the second one is going to be for the sine. Let me say for cos, so cos A sine B, this is going to be equal to half, then open bracket sine A plus B. Now the only difference here is going to be on the sign here. Here we are having a positive. For cosine we are going to have a negative, and everything is just going to be the same. So these identities are very, very important. The second one is cos A cos B. So cos A cos B is half, and then open bracket, here we are going to have cos instead of sine. Here we are going to have cos, then open bracket A plus B. Now when it comes to this one here, it is similar to this one. Now the only difference is that here we are having sine, here we are going to use cosine throughout. So the signs are just the same, like that. So here we are having a positive, so we are going to say positive. Here we are having sine, here we are going to have cos, and then A minus B, then close. The last one, sine A sine b is going to be equal to half, open bracket, cos. So when it comes to this one, it is the reverse of this one. But one thing that you need to understand here is that here we are going to use cosine throughout, but it is going to be the reverse of this one. In terms of the sine, it is going to be the reverse. So here we have a minus b. So even here we are going to have a minus b. Here we have a minus, so even here we are going to have a minus. Here we have cosine, here we are going to have cos. Here we have a plus b, even here we are going to have a plus b. So it is just the reverse. So these are the 4 identities that you need to know for product to some identities. Now what is the application? You need to know what the application. So let me just give you one example. Let's say you have been told to verify what cos 2x sine 5, and this is equal to half, then open bracket, sine 7x plus sine 3x. So which identity can you use here? Let me just do this. So we have plus sine 3x. So which identity can you use here? So you know to say that this is a and this is b. So we are using the identity for cosine. So cos a sine b is equal to half, open bracket, sine, open bracket, a plus b. Then again here, what are we going to have? Since we're talking about cosine, here we're going to have a minus, then sine a minus a b, then close square bracket. So this is what we're going to have. So 1 over 2, then sine, the value of a is 2x, the value of b is 5x. So from here, what are we going to have? We're going to have sine 7x when we add 2x plus 5x. Then here, what are we going to have? We're going to have sine or negative sine, then negative 3. So here you know to say that negative and negative, that is positive. So here we're going to have plus sine 3. So as you can see here, this one is similar to this one, so we have proven. So you can just say ends shown. So now let's try to look at sum to product identities. We talk of sum to product identities. It's more like you are adding and subtracting. So let me start with the first one. The first one is going to be sine a plus sine b. This is going to be equal to 2 sine, open bracket, a plus b, then divided by 2, then cos a minus b divided by 2. So this one you need to understand. The second one is going to be for the negative. So we have sine a minus sine b. This is going to be equal to, so instead of saying sine here, we are going to say 2 cos. So it's just going to be the opposite of these ratios. Here we are starting with sine, ending with cos. Here we are going to start with cos and end with sine. But everything is just going to be the same. So we have a plus b divided by 2. Then here sine a minus b divided by 2. So this is what we have. Second one is where we are going to add cos a plus cos b. For this one, we are going to have 2. Instead of saying sine, we are going to say cos throughout. So that is very, very important. But what we have here is just going to be the same. So cos a plus b divided by 2 cos a minus b divided by 2. Then the last one is where we're going to subtract cos. So for this one here, instead of using cos throughout, it is just going to be now the opposite. Like here, as you can see, we started with sine ending with cos. When it comes to this one here, it's going to be now the opposite. Since we're subtracting, we need to reciprocate these ratios, starting with cos and end with sine. So for this, since here we are using cos, even here cos, so for the next one we're going to use sine throughout. But what is going to happen here is that these, they are going to remain the same, and a slight difference is going to occur here. Instead of say starting with positive 2, we are going to start with negative 1. Let me say negative 2. Then say sine, open bracket, a plus b divided by 2. So this is what we have. So these are the 4 identities for sum to product identities that you need to know. So let's try to look at the application. So let's say, for example, if they have given you to find or to express this one as the product of 2 functions. Let's say you have sine 4x minus sine x. How can you go about this one here? By using sum to product. So the first thing, you need to write the identity sine a minus a sine b. If you remember very well here, we were saying it is 2 cos a, then open bracket a plus b, then divided by 2. Since here we're having cos, here we're going to have sine, then a minus b, then divided by 2. So we know to say that our a is 4x and our b is x. So we can do this. A is 4x, b it is x, and then divided by 2. So from here we know to say that here we can add and get 5 divided by 2, then x. And then here we can also subtract, and then we are going to have 3 divided by 2, and then x. Then from there now we are done. Then the next one, which I can just give you for you to try, is this one here. You just need to apply the same concept. Let's say you have cos 4x, then plus cos 2x, and this one is equal to 2 cos 3x cos x. So can you verify this one here? So for this one, for you to verify this one here, what are you supposed to do? You know to say that cos plus cos is which one? Which identity can you use here? So here we are going to say, we know to say that cos a plus cos a, let me say plus cos b, this one is equal to 2 cos, then open bracket, a plus b, then over 2, then cos, open bracket, a minus b, then divided by 2. So our value of a is 4x, and then our value of b is 2x. So here we are going to have 4x plus 2x, then divided by 2. Then here we are going to have 4x minus 2x divided by 2. So as you can see here, we have 2 cos, and then here when I add, I'm going to get 6x. 6x divided by 2, I'm going to get 3x. Then here when I subtract, I'm going to get 2x. 2x divided by 2, I'm going to get x. So it is cos x. So as you can see, this one and this one, they are the same. So you can just say ends shown. So that is how you verify. So let's try to talk about now these things that need to understand under trigonometry also. there is this part of the quadrants that you need to understand. This is the positive side of x. This is the positive side of y. This is the negative side of x, and this is the negative side of y. So let's talk about cos and sine. Right. So you know to say that this is 0, this is 90, this is 180, this is 270, and this is 360. So I'm going to try to find out what is going to happen to cos and sine. So you know to say that in the x-axis, what is the value of y? The value of y is 0. So you have x comma 0. Then in the y-axis, x is equal to 0. So you are going to have 0 comma x. So I want you to observe something here. If we say cos 0, what is going to be the answer? So you can just try to punch on the calculator and then see what you're going to get. Actually, you're going to get 1, isn't it? But when you try to say sine 0, definitely here you're going to get 0. So this symbolizes that cos means a lot in the x-axis, and the sine, of course, it means a lot, but it is giving you 0. So it is more like it is obeying this law here. Let's talk about 90 degrees. So if we say cos 90 degrees, what are we going to have? We're going to have 0. But if we say sine 90 degrees, what are we going to have? We're going to have 1. So as you can see here, this is the y-axis and it is the positive y-axis. That is the reason why we are having positive 1. So sine means a lot in the y-axis, which is the positive. Then for cos, we are having 0. So it is obeying this law here. So to make you understand what I'm talking about, it is better to take the x-axis as cos and y-axis as the sine, for you to understand things very well when it comes to plotting the graphs and other things. So what I'm going to do here is, let's try to find this one here. So this is negative x, the part of negative x. So if I say cos 180, what am I going to get? So for cos 0, I was getting positive 1 because it was on the positive side. What about 180? I'm going to get negative 1. Have you seen the differences? What about sine 180? Since it is in the x-axis, so meaning sine 180 is just going to be 0. Have you seen? What about cos 270? Cos 270, this is the negative side of y-axis, meaning we're going to have 0. What about sine 270? Since this is the negative side of y, so meaning I'm going to get negative 1 if I punch on the calculator. What about cos 360? This one I'm going to get 1 because it is on the side of positive x-axis. What about sine 360? Definitely this one is going to give you 0. So all these you need to understand them and how they are coming about, and also other angles like tan 45. You know what tan 45 is? Tan 45 is equal to what? It is equal to 1. Apart from this one, you know to say sine 30 is equal to what? 1 over 2, which is half. And then also you know to say that cos 60 is equal to 1 over 2. So there is no limitation. You need also to know these things. Now let's try to do this. Let's talk about the graphs of trigonometry. I'm going to start with sine. So let's say y is equal to sine and y is equal to cos. So we need to understand how these graphs looks like. So as you can see, this is positive. So we are going to have two things here. First one, positive sine. Then the second one is going to be negative sine x. So let me start with positive sine x. So actually, when plotting this graph here, mostly we consider angles starting from 0, then you move to 90, you move to 180, 270, and 360. So you know what it means when we talk about this. Okay. So let me do this. Let me make the coordinates. Even here, let me just do this. So I'm going to say this is going to be x and this is going to be y. I'm starting with this one. X is representing the angle, which is theta. So if I put 0 degrees here, I'm going to have the value of y to be 0. The next one, if I put 90 degrees, what is going to be the value of y? It is going to be positive 1. If I put 180, the value is going to be 0. If I put 270, the value is going to be negative 1. If I put 360, the value is going to be 0. So as you can see, this is what I'm having. What about this one? This one is just the opposite. Those which are carrying the negatives, they're going to have a positive, and those which are carrying the positives, they're going to have a negative. So this one is for the positive, and then this one is for the negative. So if I put 0 degrees, I'm going to have 0. If I put 90, what am I going to have? I'm going to have negative 1, because here I'm having positive. If I put 180, I'm going to have 0. There is nothing like negative 0. Then 270, I'm going to have positive 1. 360, I'm going to have 0. So as you can see here, there is the differences. So now let's try to plot the graph. This is x, and x is representing the angles. So I'm going to start with 0, and the next one is going to be 90. Second one, again 270. Then the last one, 360. Then here the maximum is going to be positive 1. Then the minimum is going to be negative 1. So let me start now plotting the coordinates. So we have 0, 0, or 0 degrees and 0 degrees, 0, which is somewhere here. Then 1,90, that is somewhere here. Then 180, 0 is somewhere here. 270, negative 1 is somewhere here. Then 360, 0 is somewhere here. So here I can just draw a curve which is going to look something like this. Then here, and that is our curve. So now from here we can just say this is y being equal to positive sine x. So you can also try to plot this one here and then see what you're going to have. So for this one is just going to be the opposite. So it's going to start like this. This is our first point, second point, third point, then the last point. So it is going to come out like this, then pass through this point here and this one. So for this one here, it's going to be y being equal to negative sine x. So this is very, very important to understand. Now let's try to look at what cos is. So this one is starting from 0, as you can see. Now let's see the behavior of the graph for cosine. Let me just make this one here. If I put 0 degrees here, I'm going to get 1, isn't it? If I put 90, I'm going to get 0. If I put 180, I'm going to get negative 1. If I put 270, I'm going to get 0. If I put 360, I'm going to get 1. So this is what I have. So this is y and this is x. So we have 0, 90, 180, 270 and 360. So let's start plotting. So we have 0, 1, 0, 1, which is positive 1 somewhere here, and this is negative 1. So 0, 1 is here, then 90, 0 as you can see is here, then 180, negative 1 is somewhere here, then 270, 0 is somewhere here, then 360, 1 is somewhere here. So plotting the curve, we are going to have this one here, then here it is going to start from here, passing through 90 and up to this point here, and actually here it need to be curved like this. So let me just erase this one, then draw a nice curve. Okay, it is going to come out like this. So we know to say that this is y being equal to positive cos x. So you can try to plot what negative cos is. So negative cos is that it's going to start from here, this point here, then this point here, this point here, and the last point is going to be this one here. So it's going to come out like this, passing that point, going through this point here, then ending at this point. So for this one here, it is going to be y being equal to negative cos x. Now that you know how these graphs are coming about, how you should draw them, and the differences. This one is starting from 0, this one is starting from 1, which is positive 1 or negative 1. Right, so this one can start from negative 0 or positive 0. There is nothing like that. So that is one thing that you need to know. So when you're graphing the trigonometric ratios, that is sine and cos, you need to make sure that the first thing you need to find what we call the period. Then apart from the period, you need also to find the amplitude. Those are the things that you need to consider. So period is equal to 2 pi divided by b. So you are going to understand where b is coming from and where you are going to get b. And then on top of the amplitude, it is just the modulus of a. So meaning for amplitude, you can get amplitude as a negative. So let's start with the amplitude. The amplitude is just the modulus of a. So the format has to be like y is equal to a, and then here you are going to have any trigonometric identity. Okay, or you can have y being equal to a cosine x. So now, just up to the value that you are having here. So you can have y being equal to negative 3, then sine x, and then you have been taught to plot this graph here. So what is going to be the amplitude? So amplitude is just going to be the modulus of negative 3, which is going to be equal to positive 3. So this is how you find the modulus, or let me say the amplitude. The modulus helps you to eliminate a negative. So if it was something like y is equal to 3 sine x, still you are going to say amplitude is equal to modulus of 3, which is same as 3. So this is how we go about it. Now let's try to look at how to find the period. How can you find the period? Period, it is here we have 2 pi divided by b. Okay, so when you talk of the value of b, you are talking about the value of theta. The formula, the format of the equation, it is y being equal to a. This can be sine or cos, and this is going to be b, then x plus c. This is the format. Again, you can say y is equal to a cosine, b, x plus c. This is very, very important to understand. So b is actually the theta. For example, you can be given like something like y is equal to 2 sine 2 pi x. Or you can be given something like y is equal to negative 3 cos, then open bracket pi over 4, then x. So this one is also the format. So now how do you find the period? So if here we are having 2 pi, or it can be also be written in this form here, where they are not going to give you any angle here. So if you haven't been given any angle, meaning the angle here is just going to be 1. Okay, so let me start with this one here. So meaning the period for that one is going to be 2 pi divided by 1, which is going to be equal to 2 pi. Right, so for the second one, let me talk about this one. It's going to be 2 pi divided by the value of p. The value of p is 2 pi. So meaning to say you're going to have 1. The third one, we are going to have 2 pi divided by pi divided by 4. So this one is same as 8 divided by pi, which is same as 8. So these are the things that need to put into consideration. Then when it comes to c, this one is the y-intercept or the c-intercept, I can say. So this one can be negative 2, where you can have y being equal to 2 sine 3x or sine 3 pi, then x minus 1. So this one is also the format. Now let's try to answer an example and see how you can plot the graph. So just remember the way the graph for sine looks like. It starts from 0 and goes like this. Then for cosine, it starts from 1, then goes like this. So those are the two differences that you need. Those are the differences that you need to understand. So let me just give you an example. Let me start with the first one. You are required to sketch. On the first thing here, I'm going to find the amplitude. So amplitude is equal to A with the modulus. So I can put the 3 there in the modulus, and then I'm going to get 3. This is my amplitude. So amplitude has to be in the y-axis, and period has to be in the x-axis. Period describes the interval where you are ending. Right. So finding the period here, it is 2 pi divided by b. So as you can see here, the value of b is 1. So as a result, we are going to get 2 pi. Alright. So let me just do this. See? So this is sine. This is y is equal to 3 sine x. We know to say that sine starts from 0 and goes like that. So let me just draw the xy plane. So like I said, the period is describing the x-axis where you are ending. So here we are ending at 2 pi. Now what is 2 pi? 2 pi is 360. You're going to agree with me that when you convert this one, you're going to get 360. Then 3 is the maximum. So here we're going to get positive 3, then negative 3 also. Those are things that you need to understand here. So now this is the amplitude. This is the amplitude where the angle, the maximum displacement of a wave. Okay. So from here we know that we are ending at 360. So the first one is going to be 0. The second one is going to be 90, which is pi divided by 2. The third one is going to be pi, which is 180. The fourth one is going to be 3 pi divided by 2, which is 270. So you need to know how to convert the angle from degrees into radians. So now let's see the points. The first one, we need to have 0, 0, isn't it? Because we know to say that the graph for sine comes like this. comes out like this, isn't it? So we are starting from 0, then from 0 we are ending at 90,3, which is this one. Then from there we are going to go on 180, and from 180 we are going to go on 270, -3, which is here. Then the last one is going to be 0, or 360,0, which is this one here. So this graph here, I'm not just dreaming on where to put the points. I know to say that I'm ending on 360. So from this 360, if you use the quadrant, it is going to be divided into what? 0, 90, 180, 270, and 360. So that is where now these are coming from. Then this 2, which is the amplitude, I've shown you how to find the amplitude. Then from there, just a matter of drawing a curve. Now there is something which I want to show you. What is the sign here? It is positive. Here the sign is positive. That's the reason why it is coming out like this. Now if here we are the negative, we are going to appreciate on this question here so that you understand what I'm talking about. So drawing a graph or a curve, you need to start from here, there, and then here, and then from here, this point, then that point, and then from there you're going to name this curve as y being equal to 3 sine x. And then from there now you are done. So this is the first graph that we have. The second one, we have y being equal to -2, then sine x. So the first thing here, we're going to find the amplitude. So we're going to get +2. The period, it is 2 pi divided by b. B here we can see that it is 1. As a result, we're going to get 2 pi. So it's going to be similar to this one. Now the sign here, it is negative, so it is more like you're having y being equal to negative sine x. So remember the way this graph was looking like. So we have x here. So this is 2 pi. This is going to be 3 pi divided by 2, which is 270. Then this is 180, which is pi, and this is pi divided by 2, which is 90, and this is u. Now according to the amplitude, we have the maximum, which is +2, the minimum, which is -2. So let's plot the graph. So we have 0, 0, which is here. The second one is going to be where? As you can see, here we are having a negative. Or let me even do this. Here we are having a negative, isn't it? So it can't go on the positive side. It has to go on the negative side because of the negative. So 0, 0. Then the next one is going to be 90, -2, which is somewhere here. The second one is going to be here. The third one is going to be here. Then the last one is going to be here. Plotting the graph or the curve. We are starting from here, like this, and then ending at this point here. So from here we're going to name this graph as y being equal to -2 sine x. So this is how you're supposed to plot this one. Now let's for example, if the question was like y being equal to 2, let me say 2, then sine x, meaning it is going to come out like this on this side. So let me show you. It is going to be 0, 0, which is this one, and then 90,2, then again here, then this one is going to be here, and the last one is going to be here. So you join the points. Then from here to this point here, then the last one is going to be this one. So for this one here, you're going to say it is y being equal to 2 sine x. So these are the two differences that you need to consider. So let's answer, I think, the last one. Yeah, the last one, which is this one here. We have cos 2 pi divided by 3, then x. Right, so we have y being equal to cos 2 pi divided by 3, then x. So finding the amplitude here is 1. The coefficient here is 1, isn't it? Finding the period, we have 2 pi divided by 2 pi divided by 3. So as you can see here, what are we going to have? We are going to have 2 pi multiplied by 3 divided by 2 pi. So these two, they are going to cancel each other. As a result, period is going to be equal to what? It's going to be equal to 3. So here we are not using the angle, we are using the number. That is one thing that you need to understand. So what I'm going to do here, I'm going to say we have this line here. Now this that doesn't look nice. Doing this one. So this is x and this is y. So the maximum is positive 1, the minimum is negative 1. So from here, to break this one into 4 parts as 3, this one is going to be 2, this one is going to be 1, this one is going to be 0, and this one is going to be negative 1. So it is getting to negative 1. Why? Because we know to say that here we need to have 4 intervals like this one here. We have 1, 2, 3, 4. Let me show you what I'm talking about. So even here we have, let me say we need to have 5 intervals. We have 5 dots, not 5 intervals, 5 dots, 1, 2, 3, 4, 5. So as you can see here, if we just start from 0 and end up to this point here, we're not going to have 5 dots. And remember, this is cos. So cos doesn't start from 0, it starts from where the maximum displacement is. So it is starting from here. Then from here, it is going to go on which point? So let's do this. From this point here, it is going to go on, it is going to pass on 0, not 0, but this one here. Then go on this one here, which is 2, and then the last point is going to be this one. But like I said, it is starting from negative 1. So here what you're supposed to do, you need also to include another point here. So let me just use a different color so that we have 5 dots. So if you count 1, 2, 3, 4. So the one which is remaining is going to be here, as you can see. Here our job is just to make sure that we end on 3, not increasing from 3 to 5, 3 to 4. So it's better we go to the negative side to make sure that we maintain the position. So likewise, it's going to pass there, then pass on part of 1 here, like this, then going to end on this part here. Now as you can see here, this one is positive, that's the reason why it is coming out like this. Now if it was negative, meaning it is going to come out like this. You start from this point here, you pass through at this point, then you go on this one here, there, then you're going to end on this one here. So this one is going to be y being equal to negative cos 2 pi divided by 3x, and this one is the one for positive. So this is how you're supposed to go about these graphs. So we can just end here